if we've done things properly, and to make sure we did it properly, this last number should be 0, and that's because we're doing the total here minus the number adjacent, and it should give us 0. In our case, I get 0, so it looks like I did things properly. Now, another thing to note too is my pencil is getting pretty dull, so you notice how some of these numbers may not be exactly crisp in their writing. Okay, so make sure that what you submit to me is, I guess, superior in product from what I'm demonstrating to you. Now it's time to identify the last column, how to fill in the last column, the percent passing. And let me show you exactly how to do this. You want to identify what percentage of the total amount of the sample you've weighed is passing through that specific sieve. Okay? And this is how you do it. So the idea then is that you take the value of this cell, so how much is passing each sieve, and you divide it by the total weight of that sample. So divided by, in our case, 546.44 equals to 1. So in percentage, 1 is 100. Now notice how I'm not putting the percentage value there, and that's because I've already identified that column as being in percentage. So don't give me an excuse to remove marks. There's no need to put that in percentage because it's already identified as being a percentage column. So again, let's repeat this. We want to take the value in this column, 546.44 in this case, and divide it by the total. So we get 100. Here, if we take the value in this cell, divided by that, multiply it by 100 to get a percent, we get 99.9. Voila, we're at the end. I filled them all in. I look over this to make sure that it looks clear enough. Again, because my pencil is starting to get a little dull, this 3 might be unclear. So it's just a good idea to make sure that whoever is reviewing this would actually be able to identify these numbers clearly. Lastly, when we get to the bottom, here's another check. This value should be equal to 0. That is, there is nothing that's passing your pan. And because I do get 0, that is 0 divided by that number equals to 0, it's a good check. We're ready now to move on to filling in that graph, which is the next step in trying to identify what the sample is. So the easiest way to do this is by using this on your axis right there. And then using this percent finer as the values you obtained here. Let me show you. We're going to start with the sieve that is 1.06 inches. Okay, that's basically the 26 millimeter. So what I do is I can choose to use the imperial designation at the top or the particle size at the bottom, whatever is easiest. I think I'm going to use for this one here the metric designation based on the information that I have at the top. So the 26 millimeters at the bottom is right here, somewhere here. That's 10 millimeters, that's 20 millimeters, that's 30 millimeters, so it's about here. So I'm going to bring it up there, and here's my point. It's 100% for this sieve, 100% for that sieve. Okay, moving on to the next one. The next one is the 3/4 inch sieve, and we have 100%. 3/4 inch is right here, 100%. Voila. The next one is the 1/2 inch sieve at 100%. Now the half inch is about 13 millimeters, 12.7. So I don't see a half inch up here, so I'm going to go to the metric. Here's 10, here is 20. So if I divide this into 10, right, from 10 to 20, 12.7 comes out to be about here. Okay. Next, for the number 4 sieve, we have 99.9. So here is the number 4 sieve. We have 99.9. So it's not right at 100, it's slightly below. Right there. For the number 10 sieve, we have 99.8. Okay, so it's not at 100%, but it's at 99.8. For the number 20 sieve, right here, we have 95.3. So here is 90, right, that line there. Here's a 90, and number 20, so 95.3 is basically right there. And to fill in the rest, I'll do so thanks to the magic of video editing. And we're done. So I've included all the points. I'm just going to check to make sure I have them all. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I'm going to do now is I'm going to take a straight edge. Mine is huge. And I'm going to connect these points. Voila! Now I haven't done the most superior job, but it gives you an idea of what to do. Again, I'm expecting from you something very professional, with a honed edge, or even in pen, if you're transcribing it to a new sheet. This is what a graph looks like for this specific sample distribution. Yours will look more or less the same for the one that you're going to be doing during your lab. Alright, the next thing to do is to identify your D60, D30, and D10 values. Do you remember what these are? If you don't, go back to the first online lecture I posted for you. I describe what these values are. They're essentially the size of the material that is passing 60, 30, or 10% of the sieve size by weight. Okay, let me show you how to get it. Let's start with D60. For D60, you'd go on your y-axis, find your 60, move across like this. Then once you hit this line, you would go all the way down like this, right there. Okay, and this number here, right there, is your D60. If I do this very carefully, the number comes out to be 0.39, not quite 4. When you do your lab, for the purposes of doing this the first time around, you may, if you choose to, show me this line. I'm doing it freehand, but clearly you can't, because how do you know that this is a straight line? Okay, so make sure that you don't give me an opportunity to take marks away from you by doing this freehand. See, I've done it already, so I know what that value is. Alright, so that comes out to 0.39. Then for D30, I go to my 30% passing, I go across, and I come down right here, and this value there tells me what my D30 is. So if I read it off, this is 0.1, here we have 0.2, here we have 0.3, so I have to divide this in 10 equal increments. That comes out to be 0.22. Then for D10, I go across, I come down for D10. Here's my 0.1, here's 0.2, so I have to divide this in 10 equal increments. When I do, this comes out to be 0.14. Now, be careful, you do want to go through the process of dividing these in the proper increments and reading off what you get. If you don't, if you just try to eyeball it, you're going to do a poor job. I have the benefit of having done this before, so I know what that number is going to be. So please do it. Excellent. After this pep talk, then let's move on to calculating our two coefficients, Cu and Cc. Do you remember what they are and what they're called? This one here is the coefficient of uniformity, maybe? Okay, if you don't remember, go check out lecture number, the first lecture that I posted online for you. I even indicate what the formulas are for these two coefficients. Let's start with Cu. Cu is D60 divided by D10. So if I work it out, I get 2.8. Cc is D30 squared divided by the product of D10 and D60, which comes out to be 0.89. Now I'm going to be clairvoyant and identify this as a possible location of a mistake. This is often where students will make a mistake in this calculation. Maybe you forget to square it, maybe you forget to do the division or the product correctly, but it's common that you'll make a mistake here. I would like you to prove me wrong and make sure you get that number correct. So see if you can get, just like I did, 0.89 for the calculation of Cc, based on these values